Hi to everyone. We have a very interesting sum here, which is the sum from n equal to 1 to 2020 of negative 1 to the n times n squared. This sum tends to be an alternating sum of squares, so we can rewrite the sum as negative 1 squared plus 2 squared minus 3 squared plus 4 squared right up to 2020 squared. So we discovered that if n is an odd number, the sum, we have a negative sign in front of the term. If it is an even number, we have a positive sign in front of the term. Can you actually solve this equation? Give the equation a try by pausing the video. When you come back, you verify if you were on track and if our answers correct. Alright, so let's get started. I will begin by letting my sum to be s, so I don't continuously write this nasty sum whenever I'm expanding its terms. So I will just replace it with s, and as expanded earlier, we have that s is equal to this sum. Now I'll try to group terms in pairs, so I group the first two terms, the next two terms, the next two terms, and so on and so forth. Now we all know about the difference of two squares, which says that a squared minus b squared is equal to a minus b times a plus b, meaning that the sum can be written as this. Expanding the terms, we have 3 plus 7 plus 11 right up to 4039. Now, what can we say about this? We see that it is simply the sum of an arithmetic sequence. The arithmetic sequence is simply defined as an is equal to a1 plus d into n minus 1. N is the number of terms, a1 is the first term, and d is a common difference, which is the difference between any two consecutive numbers. Alright, now we need to find the number of terms, but I think it is clear that we have 2020 divided by 2 terms, because we originally had the sum from 1 to 2020, which is 2020 terms. Now we paired the terms and we have a final sum here, meaning that since 2020 is even, therefore we never left any term out. We paired all the terms that are involved. So simply the number of terms of the new sum is half of the number of terms of the original sum. So by default we have 1010 terms, but let's actually verify if that is true. Now in an arithmetic sequence, we can identify that the nth term is obviously the last term. Here our last term is 4039, meaning an is equal to 4039. a1 is our first term, which is 3, and d is our common difference. 7 minus 3, 11 minus 7, and so on have the same value, which is constant. That is 4. That's why we call it a common difference, which is common although. Alright, so fitting everything back into the formula of the arithmetic sequence, we obtain this. Now we want to find n, which is the number of terms, so n simply give us 1010, meaning we were actually correct. Now we actually want to find the sum. Now we know that if we have the first term and the last term and the number of terms, we can actually find the sum of the first n terms, provided it is an arithmetic sequence. So from there we have 1010 on 2 into 4039 plus 3. Simplifying and expanding, we have our sum to be equal to 2,041,210 as the final answer. So I'm very excited to actually solve this sum, because at the beginning it was very nasty and a little bit confusing, but at the end we are able to demystify the sum to have a finite value, which is what we're actually looking for. So if you love the video, I would like you to like the video, you comment on the video, and you share the video. Now if you want to actually see upcoming videos in this channel called Mafa, then I beg on you to subscribe so that you'll be able to receive notifications. That's provided you turn on your notifications so that whenever I post a video, you'll be one of the first people to receive. Thank you.